Hello, welcome to week 2 of intermediate algebra. Today we're going to play around with some factorable equations and some functions. Let's take a look. So this week we've got quiz 2 is due. You should have or be finishing up section 1.3 from last week about special formulas. And section 1.4 you should be finishing up on Tuesday and then reviewing and starting chapter 2. So the material I'm going to go over today is mostly from section 4, and I'll show you a little bit of 2.1 and 2.2. Remember, for the quiz, you can write everything down on paper. You don't really need to print this out, but you do need to look at it to see the problems. Once you take a picture or scan your work, you can use the submit button here and either upload your file there, or if it's maybe in a Google Drive, you can give me the shareable link in the text entry section. But I think most people have an image to upload into Canvas. The quiz has a bunch of equations to solve. And these are all the basic kind in that they already have 0 on one side. And I'll do one example toward the end of an equation that doesn't have 0 on the other side and how to handle that. So this is your quiz. I'm going to do some similar problems. Let's start off with this one right here. So let's make that a touch bigger. So we're trying to solve this equation right here. And it's different than just factoring because there's an equals and there's stuff on each side. And the equation said, and the problem says solve. So focusing on this right here, I'm going to apply what's called the zero product property. You want to use the zero product property. There we go. Anytime you have a polynomial, typically it's going to be of degree 2, so it's going to have like a square in it, maybe degree 3 or degree 4, cube or 4th power. We don't get to do much higher than that. It gets too hard. There we go, magic pen. So the zero product factory set, I don't know why I can't say that today. First, step 1 is to get 0 on one side. Well, we already got that covered. It was given to us that way. Then step 2 is to split on the product. So product means the result of multiplication. Well, here is my multiplication right there. And so I get to split this into 2 problems. And one problem is 8 times x plus 3 equals 0. And you can only do the split if you have a product and a 0 on the other side. So the other one, let's write that in a different color. How about red? The other one is 9x plus 4 equals 0. So I'm just breaking this into 2 different problems. Draw a line in between. Solve this one right here, I would subtract 3 from both sides. So I get 8x equals negative 3. And then I would divide both sides by 8. So I think x is negative 3/8. I think that's one answer. I don't know yet. Let's do the other one. The other one says 9x plus 4 equals 0. So to get rid of the 4, we subtract it to the other side. So 9x equals negative 4. And then dividing by 9, I get negative 4/9 for the other possible answer. So I'm going to circle those now, believing they're my answers, because I think I've solved here for x. Whoa, crazy button. And I think this is the other answer right there. Next thing I want to do is check. And the only way to check is to plug into the original when you have an equation like this. Anytime you're solving an equation, you plug back in. So I need to plug x equals negative 3/8 back in. So that's going to give me 8 times negative 3/8. And always put it in parentheses when you substitute in. Plus 3 times 9 times negative 3/8 plus 4. And I think, question mark, this is equal to 0. Now, let's see, 8 times negative 3/8. You could view that as 8 over 1. And so the 8s, since I'm multiplying, they divide out. So that gives me negative 3 plus 3 times whatever this is. Negative 3 plus 3 is 0, and 0 times whatever is, excellent, it is 0. And that matches the 0 I have on the other side, and so it does check. Checking the other one, kind of running out of room there, I've got negative 4/9 for x, and I'm plugging that into 8 times that plus 3 times 9 times that x value plus 3. Now, the other time I was kind of messing around being silly. I just said this one was a whatever. This one I'm actually going to do it out. Viewing that as 8/1, 8 times 4 on a good day is 32. In this case, negative 3. I need that to be a fraction. 3/1 with the denominator of 9. So that means I'm going to have to multiply 9 by the top and the bottom. That's going to be 27/9. And that's still inside the parentheses. So I'm just following the order of operations. So let's see, 27 to 32 is what, 5, but negative. So I get negative 5/9 there. Other side, 9/1, multiplying, the 9's divide out. So that gives me, oops, I made a mistake there. Thanks for pointing that out. I heard one of you there online in the future telling me that I messed up there. Job. So here I have negative 4 plus 4. And that is 0. 0 times negative 5/9 is definitely 0, which matches what I had on the other side. And so this does indeed check. All right, let's try another one. So just going back, did I circle the right answers? Yep, I think that's an answer, and that's an answer. Circling both again for fun to emphasize these are my answers. This stuff up here is my work, and then the next part and page are my check. All right, another one. This one is not already factored, so we got to figure out how to factor it. So make a note that is 1p squared, so I only need to consider the negative 14. So I'm using before what I called that AC method. A, 1 times c, negative 14, is negative 14. The negative tells me that I'm going to subtract the factors that I find. 14 factors as either 1 times 14 or 2 times 7. And I know on a good day that 2 minus 7 is negative 5, which is the middle coefficient right there. So I found the magic combination. Two ways to proceed. One way is to just write the factors down. I'm going to show the factor by grouping method just for fun. So factor by grouping method says once you find that magic pair of numbers, split the middle term. So I'm going to say that is p squared plus 2p minus 7p minus 14. And I'm going to ignore the equals 0 for now, and I'll come back and solve after I factor. With the factor by grouping method, once I break it into 4 terms, I ask what's common to the first 2. And there's a common factor of p, leaving behind a p plus 2. Next part, what's common to these two? Well, I have to take the negative out front. That is mandatory. So I'm going to factor out a negative number. And then otherwise, they have 7 in common. So if I factor a negative 7 out, that's going to leave me a positive p and a positive 2. And hey, coincidentally, those guys match. So p plus 2 is the common factor. And p minus 7 has to be the other factor. Now I can come back to that once I have it factored, that this is equal to 0. And the 0 product rule says to split on the product. So either p plus 2 equals 0. Subtracting 2 from each side, I get p is negative 2 as one possible answer. Other possibility is that p minus 7 equals 0, adding 7 to each side. My pen's having a hard time keeping up with me today. I get p is 7. There's another possible answer. And we'll circle that. Am I right? I have no idea. got to plug back in to check. So I'm going to come to a new screen for that. I'm running out of room. So checking this, so one answer, let's see, is -2. So to check, you basically, anywhere there's a P or an X or whatever, you just put a pair of parentheses. And then what you check gets dropped into that parentheses. And we're hoping that it works out. In this case, what are we plugging in? First, we'll plug in the -2. And be careful with your signs. Negative times a negative is a positive. Negative times a negative is a positive. 4 and 10 is 14. Minus 14 is indeed 0. And so that's just what I was hoping for there. All right, let's check the other one. Stay put, please. Get everything? Almost. Again. Gotcha. And we'll just shrink that a little bit. Oops. All right, check the other one. Someday we'll have paper that does this. We want to check P equals 7 also. So that's going to be parentheses squared minus 5 parentheses minus 14 hopefully equals 0. Dropping in my 7, I get 49 minus 35 minus 14 equals 0. And let's see, to get from 35 to 49, I need 5 and 9, which is 14. Ooh, look at that. That works out nice. Minus 14 is another 0. Woohoo! We did it. All right, checked. These are indeed the answers over here. They both work. Well, they always both work. In this type of equation, if I did this stuff right, yeah. But don't take it for granted. Always check. All right, let's try another one. P squared minus 25. There's two approaches to this one. We could apply that AC factor by grouping method, or we could memorize a formula. So hopefully you did a good job in section 3 and you memorized the formula. A squared minus B squared is equal to A minus B times A plus B. And in this case, my A is the same as the P, and my B would be A5, because 5 squared is 25. So this must factor as P minus 5. There's my A and my B. P plus 5. All right, so now I believe that P minus 5 times P plus 5 equals 0. So 0 product property, I got it right that time. We got our 0, we have to get our product, got it. Once you get the product, you split it. So P minus 5 could equal 0. Adding 5 to both sides, we get P equals 5 as one possible answer. Other possibility is P plus 5 equals 0. Subtracting 5 from each side, we get P equals -5 as another possible answer. Are we right? I don't know. Let's check. To check, go back to the original. Plug it in and pray. So the original says something squared minus 25 is supposed to equal 0. We think that 5 is one of those numbers. Let's see, 5 times 5 is 25, minus 25. Yep, that's 0. Other possibility is -5 squared. Remember I said always put in parentheses when you substitute. Important, especially if you have a calculator. -5 times -5 is positive 25, minus 25. Yep, that's 0 too. Check. We are kicking butt here. Let's do another. All right, blow that sucker up a little bit. We got m squared plus 7m equals 0. All right, so this one is interesting because right away I can get a greatest common factor. Greatest common factor is m. If I factor the m out, I get an m plus 7 left behind. Now, the cool thing about a greatest common factor is I've just made this into a product. So the zero product rule says either the first piece, m, has to be 0, or the other one, m plus 7, has to be 0. This one is deceptively easy. Well, m is 0. There's one possible answer. Subtracting 7 from each side. Ooh, might have to put a 5 there. That's bizarro. I get m equals -7 as another answer. So I think I found 2 answers. And then it's up to me to check. Always check in the original, not some altered version you made up. So I think that whatever squared plus 7 of those same whatevers is supposed to be 0. Let's check the harder one first. Usually negative numbers are trickier. -7 squared, that's -7 times -7. That's positive 49. Here I have positive 7 times -7. That is negative 49. And yep, that is 0. Check. Otherwise, plugging in 0 plus 7 times 0 is 0 plus 0, which is 0. And that's supposed to equal 0. That's a whole lot of zeros. We did it again. So, work, answers, check. Anytime I give a quiz, I expect to see work, answers, check. Once in a while, the problem's easy enough to do in your head, but not always. All right, let's try one a little harder than what's on the quiz. So those were similar to the quiz questions. This is a problem in your homework, section 1.4. All right, so this one says -2 equals -3t squared plus 5t. So here I have stuff on each side of the equation. I don't have a 0 yet. So let's get it. There's 2 approaches to this one. One approach is to just bring this -2 over to the left. So I do that by adding 2 to each side. And notice that t squared t and no t, those are not like terms. So the best I can say is that I have -3t squared plus 5t plus 2 on the right side. On the other side, I have a 0. Hey, I get the 0. Now I need to go for the product, so I have to try and factor this. I'm going to use what I called the AC method. My A is -3. My C is 2. -3 times 2 is -6. What does the negative mean with the AC? Think. Yes, it means that we're going to subtract factors. If it's positive, you're going to add factors. 6 factors as 1 times 6 or 2 times 3. Now, this is a good thing to know that I'm subtracting factors, because although I can add 2 and 3 to get 5, in this case, I want to take 6 and subtract 1 to get a 5. So I'm using the signs of AC as a key on how to combine the factors, because sometimes there's more than one way to combine the factors to get the middle term. Sneaky little suckers. All right, so then what I do is I use these magic things to replace the middle term. So I'm going to rewrite this as -3t squared. That sucker stays the same, but I've discovered over here that 5t could also be a plus 6t minus 1t. And you could just call it minus t if you want. I like to put the 1 in there. All right, I'm going to ignore that 0 for just a minute because I'm going to apply the factor by grouping, which says when you have 4 terms, what's common to the first 2? So let's see. There's a 3 in common, and the question is, do I want to take that negative or not? You could or you could not. It doesn't matter. I think I'm going to take it today. So I'm going to factor out a -3. Question, what does that leave behind? Let's see, a negative goes into a negative, leaving a positive. Oh, I forgot the t. 3t. Leaving a positive t. And those of you in the future watching this, when I make a mistake, make sure you say something so I know. And then let's see, negative goes into a positive, negative, and then 3 goes into 6 twice. All right. Over here, you always have to factor that middle sign out. So if that middle thing is a positive, you write a positive. If that middle one is a negative, it's a negative. So I got to factor out a negative number. Otherwise, what do these guys have in common? Well, you might say nothing. However, factor of 1 is always common. So I'm going to say it's a -1 that's common. This is important here. All right, so the -1 goes into -1t, leaving what behind? And I think, I kind of messed up the color scheme here, didn't I? Let's clean that up just a touch. This is a red, and this is red, and the parentheses get to be red. All right, back to it. Let's see, negative goes into a negative, leaving a positive. Negative goes into a positive, leaving a negative. And that's a wonderful thing because these guys do match. So I have a common factor of t minus 2. And the other factor is whatever's left when I take the t minus 2, which is a -3t minus 1. And just to be a little more thorough here for factoring completely, these two are both negative, so I could factor this one step further by pulling out a -1 as a factor of this 3t minus 1, which leaves a 3t plus 1. I still have the factor of t minus 2. And it doesn't matter what order you sort these suckers out, so I could say this is -1 times t minus 2 times 3t plus 1. So now it's factored completely. I still need to solve, so I need to bring in that equals 0. Let's throw it on this side and pick up. All right, so new page. We've got -1 times t minus 2 times 3t minus 1. That equals 0. Zero product rule says you get to break it up on the multiplications. Well, -1 can't possibly equal 0, so that's useless. T minus 2 could equal 0. Adding 2 to both sides, we get that t equals 2 is one possible answer, hopefully. Otherwise, that's supposed to be a plus. 3t plus 1 equals 0. Subtracting 1, 3t equals -1, dividing by 3, t is -1/3. And this is why we check. So earlier I made a little mistake right here. I had a negative instead of a positive that it was supposed to be. Possibilities for sign errors all over the place. This is just an educated guess, these two numbers. To see if they're really true, I got to go back, grab that original here, and plug in and pray. So I think I have solutions to that right there. So let's check. So to check this, let's switch maybe red. -2 equals, and then I start throwing some parentheses in instead of a t. So -3 parentheses, let's check the 2 first. And then we have 5 times 2. And there's really not much to do on the left side. I just have a -2. The right side does work. So 2 squared is 4. 4 times -3 is -12. And then 5 times 2 is 10. -12 and 10. Yeah, it's -2. We did it. Check the other one. -2 is supposed to equal -3 times -1/3. Ooh, we have fractions and a negative. We can do this. We got it. Don't sweat it. Just got to be careful. Notice how I'm trying not to use a calculator here. Anybody know why? There's 2 reasons. Yeah, one is the quiz says don't use a calculator. Number 2 is half of your final exam is without a calculator. And you got to be able to do this stuff without a calculator. All right. Squared. Negative times a negative is a positive. 1/3 times 1/3 is 1/9. Multiplying that by 3, we'll call that 3/1. 3 goes, ooh, weird, crazy pen. 3 goes into 9 3 times. So that gives me a 1/3. Over here, I've got, let's call that 5/1. Nothing cancels. 5 times -1 is a -5. Denominator, 1 times 3 is a 3. We have a common denominator. So 1 minus 5 is -4. Uh-oh. I got a problem. Oh, I miscopied right there. You see that? I heard somebody saying something off in the distant future. That's a -3. So that's a -1/3. -1 minus 5 is -6. Ooh, this looks way better. I was just seeing a bad answer there. -6/3. 3 goes into 6 twice, but it's negative, and it works. Ooh, that was close. So what if it doesn't work? A couple things could go wrong. Maybe you made a mistake in the arithmetic like I was about to do. Maybe the answer's wrong. It's hard to know. What I usually do is if I don't spot the mistake quick, I whip out another piece of paper, blank paper, and I try again. Clear my mind, take a deep breath, stand up, do a little circle, sit back down. Usually helps. All right, next, let's try something else. Where are we? Okay, so here's a little harder. This is different than the quiz. I'm not asked to solve here. I'm asked to factor. And I'm given a hint about one of the factors, but I'm going to ignore that. I'm just going to apply the AC method to this and see what happens. So the AC, 10 is my A, and 280 is my B. This is a little harder than I would put on the exit exam, so you'd probably have an access to a calculator to do this one. First thing I do in a problem like this is I ask, is there a common factor to everything? 10 and 28 are even, 43 is not. I think 43 is prime, so I'm kind of screwed. No common factor. So I've got to take A times, ooh, I wrote B, but it's really a C. There we go. A times C, 10 times 28 is 280. Since it's a positive, I'm going to be adding factors, but now I got to find them. So carefully whip out my calculator maybe. 1 times 280, that ain't it. 2 times 140, that ain't it. Let's see, 3 does not go into 280. 4 goes into 280. 4 goes into 28 7 times, so 70. 5, yeah, 5 goes in there. 5 goes into 280, 56 times perhaps. This is where calculator would be nice. Okay, 5 goes into 28 5 times with 30 left over. Yep, 56, lucky guess. All right, 5, 6 doesn't work. 7 works. 40 times. I've got that 43 yet. 7, let's see, 8. Hey, I think 8 works, doesn't it? Yes, it does. 8 works. 8 goes in there 35 times, I think. 8 goes into 28, how many times? 3 times. That's 24 with 40 left over. Yeah, 35. What's 8 and 35? Oh, it's 43. Bingo, I found it. All right. Whew, that was kind of close. That was a tough one. All right, we did it, though. Just got to work at it. So just reminder, 8 plus 35. Count on your fingers. I do all the time. Is 43. All right, so then we rewrite the middle term. So I got 10x squared plus 8x plus 35x plus 28. All right, so that was the point of all that, to rewrite the middle term. So now I'm ready to factor with variables. First pair has a common factor of, I think, 2x. What's left behind if we pull out the 2x? 5x and a 4. Yeah. And I know I got the greatest common factor is if the two things left don't have anything in common. And 5x and 4 only have a 1 in common. All right, and then what do we got? We got a plus, because there's a plus in the middle. Oh, that's plus, not a 4. 7. 7 goes into 35. And this is always a guess, and we just hope it's right. 7 goes into 35 5 times. There's an x. 7 goes into 28 4 times. 5x and 4 have nothing in common. Ooh, and it matches. Check it out. Nice. So we pull out the match. 5x plus 4. And whatever's left is the other factor, 2x plus 7. Woohoo! Are we done? It said factor, so we're done, sort of. Then I should multiply it out to check. Check. What happens when I multiply? 5x times 2x is 10x. 5x times 7, 5 times 7 on a good day, I think, is 35. Oh, I missed something, 10x squared. 5 times 7 is, yes, 35x. 4 times 2 is 8x. And then 4 times 7 is 28. Let's see, 35 and 8 is 43x. And do the signs match up? Everything is positive. Everything, oops, that's an 8. Everything is positive. I think that matches right there. Yep, check. I got it. All right, that's called the AC method. Factor by grouping is part of that. Cool stuff. One more problem. All right, chapter 2, functions. What the heck is a function? A function is a mathematical equation with a couple variables or more in which you have an input variable. So this thing's designed for me to plug in numbers, and I have an output variable. Output. The input variable is often considered the independent variable. Independent. And the output depends on what we plug in, so it's the dependent variable. And just to double check, you graphed plenty of these things and played with plenty of these in a previous math course. This equation is in slope-intercept form. It's a line, and it's designed for me to take numbers for x, like -2, and plug it in and see what y is. -2 times 2 is -4, -1 is -5. Maybe I'll plug in -1 times 2 is -2, -1 is -3. Maybe I'll plug in 0 because that fits my nice pattern here. 0 times 2 is 0, -1 is -1. Plug in 1 times 2 is 2, -1 is 1. And it only takes 2 points to make a line, but usually I plot a couple extra just to make sure things are going well. So let's see, this is my shaky y-axis, and here's my shaky x-axis. And let's say 1, 2, 3, 4, 5. This is 6 way out here. 1, 2, 3, 4, 5. This is -6 out here. I'm assuming it goes the same the other way. Y-axis, 6, and -6. And to plot these points here, let's see, we got -2, -1, 2, 3, 4, 5. And we get -1, 1, 2, 3. Ooh, they're lining up so far. Oh, no, 2 points always make a line. Never know. 0, -1. And 1 goes with 1. Yeah, they line up. Look at that. I think I did all right. Line. Something like that right there. Oh, yeah, that kind of sort of works. All right, so there's my line. All right, so what the hell does this have to do with being a function? Good question. So a function is, again, some kind of equation where you can say there's an independent variable and a dependent variable. And the catch is that for each input value, that's your x, input value. Whoa. Sneaky pen, sorry about that. There is no more than one output value. What does that mean? Well, they could be one or it could be no output. It's possible to plug something in and not get an answer. Check with our calculators later. More than one output value. Okay, so let's check to see if that's true. Well, for example, the input -2. I think we all agree -5 is the output. If the input was 0, I think we all agree that -1 is an output. So in this case, I can say that this meets the definition of a function. So that means y is a function of x. Okay, simple statement. It's a lot of words for math, so usually we abbreviate that. Y is equals, function is f, oops. In math, a lot of times a parentheses is of, and then x. So I have this new set of symbols, f of x is the way you read that, f of x. And all it means is y is a function of x, meaning it matches this definition right here. Okay, so the function notation is going to be useful. Since I have an equals in between, then the thing called y means the same thing as the thing called f of x. So now instead of seeing equations like y equals 2x plus 1, you're going to see equations that say f of x equals 2x plus 1. What does that mean? Well, it means two things. One, this statement right here tells me that f of x is just a y value. And the other thing it tells me is that the way I wrote the equation, that anytime I plug in an input value, I'm going to get only one output value. I might not get an answer, but usually I will. That's the basics of a function. Lines form one kind of function. Okay? There's other ones, and I'll talk about those in the next video. Have a good day. Do good math. I'll catch you in the future.